Hi and welcome to Unit 2, Topic 1, Video 4, and in this video we're going to start investigating and exploring some applications using trigonometry. Okay, so there's quite a few contexts that we can use in the realm of trigonometry, or we can use trigonometry to solve, and a couple of specific ones we're going to do a bit later, but here's some really general ones, a really simple one, and one where maybe it's a complex for me, the larger question's being asked. I'm not writing the whole question up, I'm going to narrate the question to you, so you probably work it out here, but here you might not be able to work out what the question's going to be. So in this question, I've got a rectangle, poorly drawn. I didn't actually meet the corner, so maybe I'll try and do that better next time. But in the meantime, it's a rectangle, base length 10, height 4. Because it's a rectangle, I don't even need this. If I'm told it's a rectangle, I know it's right angled. And I'm trying to find this angle here. What is the angle? It might be asked in a question, maybe it's a written question. What is the angle that the diagonal makes with the base? That would be this angle. Or maybe what is the angle the diagonal makes with the height would be that angle. So just be aware of how to read and understand and interpret those questions. Now, I want to find theta. Got a right angle. I've got two side lengths here that don't matter. I just care about this right angle triangle here. So I've got 4 and 10 opposite and adjacent. Therefore, I'm working in a tan ratio. Tan theta is equal to opposite over adjacent. So therefore, tan theta is equal to 4 over 10. Note here my expectation. It's going to be low. 4 is lower than 10. So I'm expecting it to be, I don't know, maybe 25 degrees. Something lower than 45, that halfway mark. So now, theta is equal to tan inverse of 4 over 10, or 0.4 if you like. And we get shift tan of 0.4. That's equal to 21.8. 21.801409 ... And we'll write our approximate answer as 21.80 degrees. 2 decimal places, as expected. So there's a simple interpretation type example. Here's maybe a slightly tougher one. So the question is, I've got a ladder leaning up against a wall, and it's at an angle of 37 degrees. Now my ladder, fully extended, is 5.4 metres. I want to know how much higher can I reach up the wall if I increase my angle of inclination by 30 degrees. So I want to know what happens then if I increase that. So what I'm going to do is I'm going to update the diagram a little bit, maybe here. I'll pop a bigger wall. I didn't want to give away too much before. There's my 37 degrees, there's my increase. 37 degrees, there's my plus 30 degrees. This is some height. Obviously the wall we assume is at a right angle with the ground. That's an assumption we have to make. And I want to know what is this value here. What is the difference between there and there? How much extra height can I get? And that's an interpretation question. I would see a question like this where somebody might just calculate that height. Or maybe just that height, and not actually consider the question's actually asking you to find this height here. So let's do our calculations. We'll start in our small one. Remember we've got 5.4 metres, and so 37 degrees, 5.4 metres, which is our hypotenuse. I'll do it up here. Hypotenuse, 37 degrees, and we want to find the opposite side. So we'll call this one, actually no, we won't call it x. Yes, we will call it x because I've already used h for height. We'll call it x1 now because it says x1 and x2. Okay, so I am dealing with sine. Sine of theta is equal to opposite over hypotenuse. In this case, that's sine of 37 is equal to x1 over 5.4. And therefore, x1 is equal to 5.4 times sine of 37. Get out your trusty calculator, throw her in there, 5.4 times sine of 37, and of course that gives us, of course, he says, as if it was obvious, 3.25 rounded to 2 decimal places. Right, I'm going to keep this answer though, so I might just make a note here, 3.249801125, because I might need that information later on. So there's the first part. Now I need to find this second height here. So I want to find this overall height here. Now this is where the diagram I've just drawn, which is a really common interpretation of this question, is not very good. Because let's just take a second to imagine, if you have a ladder leaning up against a wall and you move it to increase the angle by 30 degrees, you don't just get the ladder and pick it up like this. You have to push the bottom of the ladder in as well. So we're going to end up with a ladder not here, but it's going to be more like here. And that's going to be 67 degrees, and this is still 5.4 because the length of the ladder hasn't changed. That's the assumption we've got to make. So I'm still dealing with a tangent ratio, a sine ratio, because I've got my hypotenuse and I've got my angle. I just don't have my height. So I'm going to call the height x2, and I'm going to now do sine of, and I've already written out my rules, so sine of 67 is equal to opposite, which is x2 over 5.4, the length of the ladder, and I multiply that across. 5.4 sine 67 equals x2, and therefore x2 is equal to, and just change the number in the calculation, 4.97, or approximately 4.97072629 ... So you can get that value, and of course therefore the gained height is going to be this x2, that should sort of be up to there. Diagram again, so we'll just do this. And x2 minus this length, which is x1, and our gain will be there. So therefore height gain equals x2 minus x1, and I might be about to run out of space, but x2 minus x1 is 1.72. And I don't know, meters is given in the diagram, so we can finally use some units and we'll pop it in meters. Okay, so there's a couple of examples of questions you might see. That was a little ambiguous because I didn't tell you everything at the start, but notice there was a couple of little assumptions we had to make, like this wall is at a right angle with the ground, because if it's not, we can't do the question. So if you're not told that, you might have to make that assumption. And also that the ladder, you do have extendable ladders, so maybe it's a ladder you can change the length and keep it and you just make it longer, but I'm going to assume it's the same length ladder. 5.4 meters is pretty long for a ladder already. All the best.
Well, obviously this is not an exhaustive list of different applications, so it's definitely worth just jumping in, trying some questions out and asking questions when you need help. All the best.